Wow, I didn't even have to call the room to order. We have a great audience, I can tell already. Thank you very much for joining. How is my audio for folks in the back? Okay, Kaisa says it's good, so we are good to go. This thing is arguably more important than me tonight, so I'm glad I have it here. Thank you all for coming to the 2024 James A. Kelly Learning Levers Prize Competition, a competitive award to recognize, encourage, and support innovation in education. We're in for a treat tonight. We have 5 great student pitches to hear. You are not here to see me. You are here to see them. You'll have to indulge me for a little bit before we get to the student pitches. In as short an order as possible, because that really truly is the main event. And it will go by fast. I say it every year, but this is the fastest 2 hours of my year, and it might be of yours too. So our agenda for tonight, I promise I'll introduce myself at some point. We'll do some introductions, very brief introductions. We'll have a video of Marshall Dean Elizabeth Bermoji. She could not be here tonight. She really wanted to. As you'll see, she also appreciates this event, and you'll get a video message from her. We'll talk about our program background, familiar to some, perhaps new to others, but we like to contextualize what we're trying to do with this. And then we will introduce our judges, briefly introduce our teams, and then you'll hear from our 5 teams in short order. There'll be some pitching and then Q&A between each team, and then the judges and I will abscond to a room just short distance away while the audience has a chance to have question and answer and just discussion with the teams here to learn more about what they're doing and ask any burning questions that they might have or they thought the judges should have asked. And then we will end the night by announcing our winners and with a lot of fanfare. So, introductions. My name's Nate Phipps. I'm Managing Director for CEDAR. CEDAR is the Center for Education, Design, Evaluation, and Research here at Marshall Education. I will be your MC and collaborating with tech support here as well, troubleshooting. We also have Kaisa in the back, Kaisa Riding, who's our chief tech supporter, and will be, you'll see her throughout the night, but I'll also do my best to be sort of timekeeping and just helping things along. I'll also be chief interrupter for questions to keep us moving. And I have Darren Stockdale here as well, CEDAR Instructional and Program Design Coordinator and Lecturer. And he is going to be helping with timekeeping and also as a resource for the teams throughout the process. So that's our team, small but mighty. I'm going to let Elizabeth say, as only a dean can, provide some remarks and thank some of our sponsors and acknowledge some of the other folks in the room. And if all goes well, you'll see Elizabeth playing seamlessly in just a moment.
Welcome to the 2024 James A. Kelly Learning Levers Prize Competition. I'm Elizabeth Bermoji, Dean of the Marcel Family School of Education. This is truly one of my favorite events of the year. I'm often asked to envision what the future of education holds, particularly regarding educational technologies and digital tools. This year, those questions seem more pressing than ever as we see technologies such as artificial intelligence and virtual, augmented, and mixed reality tools become ubiquitous in our society. The Learning Levers Prize Competition is a wonderful opportunity for us to support our student entrepreneurs and designers as they share their ideas for leveraging exciting new technologies that enhance learning and advance education. There are many people responsible for making this competition possible. First, an enormous thank you to Nate Phipps and his team in the Center for Education Design, Evaluation, and Research for planning and coordinating this extraordinary opportunity for students. I also want to thank the many Marcel School faculty and staff members who provide support throughout the process. I'm grateful to our panel of judges as well for contributing their time, expertise, and enthusiasm. Now, I also need to express my appreciation for our sponsors, the Entrepreneurship Minor, the U of M School of Information, and to generous individual benefactors. For example, Mr. Henry Tong has given both expertise as a judge and financial support. Paul Diamond launched the James A. Kelly Prize competition originally with a generous gift to fund the prize. And most notably, to James A. Jim Kelly himself, who inspired and has helped fund the gift, as well as his family and friends who have given generously to honor their patriarch and their friend. Of course, the Learning Levers Prize would not be possible without its participants. This year's participants have produced some truly innovative designs. This year, extended reality and artificial intelligence have a strong presence in our proposals, and several have incorporated mixed reality tools by including physical experiences. First, Climate Chaos is here to turn the heat down on the competition and on the Earth. Code Block will introduce us to another kind of environment in their dynamic coding playground. Kids AI recognizes that for children to drive the future of AI, they might need some driver's education. Math Myths will have us co-creating numerous stories. And String Theory might help us deduce our prize winner by sharpening our logic skills. As a reminder to everyone, all of these teams are competing for two kinds of awards. First, development awards for teams whose designs merit support for continued development. And then one Learning Levers Award will be given to the team whose design is judged most likely to take off with just a small investment of funds. Regardless of who takes home the big prize, each of you should be proud of your inventions and of your efforts to change education and learning in positive ways. Thank you, Learning Levers participants, for taking on this challenge. I wish you the best in the 2024 James A. Kelly Learning Levers Prize competition. Go Blue.
Okay, we can give Elizabeth some applause.
In absentia, thank you, Elizabeth. I truly agree that this is one of the best. This is one of the best nights of the year for me. Best afternoons, I should say. I'm used to doing this event at my home office, and like the sun here in this room is truly amazing. This is one of my favorite rooms at the School of Ed, and you can see why, especially on a day like today. So a little bit of background to our program for those that don't know. We are not so young anymore. This is our 6th year in our current iteration as a sort of independent program dubbed Learning Levers. We were previously part of Innovation in Action, if you're familiar with that, and sort of spun off with support from Paul, Jim, and others, support and encouragement, I should say, to really establish a dedicated program for pre-K through 12 tech-enabled innovations. Can you folks see okay? All right, you got out of class? Nice. Okay, great. So here's where we exist in what others have called the entrepreneurship and innovation ecosystem here. This will be a familiar slide for folks that have attended, but basically we seek to take on and support teams that are in their earliest stages all the way to their most mature stages. It's really, we see a big tent opportunity. The caveat being that we focus relatively narrowly on pre-K through 12 learners and how to sort of provide levers, if you will, to enhance their learning. And so that's where we sort of have found our niche, and we think it's an important one. And so a lot of the teams you'll see tonight have taken part in other programs, will take part in additional programs, both within and outside the university, and have sort of, come in with lots of different experiences, as you'll see. Some of them have participated in things like Innovation in Action, Optimize, the Michigan Business Challenge, courses. We receive a number of proposals that are born out of course designs, curricular experiences. We are a co-curricular. We are not a credit-bearing experience. So these teams are doing this sort of on their own outside of class credit. And then we expect these teams to sort of move on to launch into other programs like the Zell Lurie Institute, lots of other supports within the UM ecosystem, and then, of course, outside supports, including funding. We seek to be a support particularly for expertise on teaching and learning, research on sort of best practices around education. That's what we do best here. And so that's where we see our niche. And we encourage all the teams that are here and the teams that propose to stay in touch with us, regardless of the outcomes tonight. So why Learning Levers? Again, this is something this is sort of our rock. We have this here to remind us each year why we started doing this. And so I will read Jim's words. This is from Jim's charge to us in 2016. So why Learning Levers? Children and young adults have tremendous untapped capacities to learn at faster speeds, to learn more deeply, and to learn more broadly. Tapping into and stimulating this underdeveloped capacity is one way to describe the challenge of the Learning Levers Prize. We hope this process will result in widespread and intensive use of Learning Levers to support and encourage and motivate future generations of students to learn lots more and to learn lots more effectively. Thank you for that, Jim. And we won't really go into sort of where our teams go, but I will just say it's nice to look at this and know that the teams that have gone through Learning Levers have had true impact. And you'll see one of our former winners is here tonight. You'll hear a little more about that. What's next? Oh, I think it's our judges. I should know this by now. So I'll introduce our judges and then we'll quickly introduce our teams. And then again, I will get out of the way. So we have 4 wonderful judges arrayed roughly in the order you see them here on the slide. So returning as both a judge and participant is Carl Haynes Magyar. And I will I'll read off the slides here so that I don't miss anything. Carl C. Haynes Magyar is a Presidential Postdoctoral Fellow at Carnegie Mellon University's School of Computer Science and the Human-Computer Interaction Institute, and creator of CodeSpec, a web-based computer programming tutor built on Ideas Plus. That's an acronym, and I don't think I'll get it right, but those are really powerful ideas. He received his PhD at the University of Michigan School of Information in 2022 and a master's degree in Library and Information Science with honors from Syracuse University's School of Information Studies, iSchool, in 2016. Carl's research has produced computer science instruction and assessment that increases engagement and optimizes learning. And because we love to give out prizes, we're giving out prizes to our judges too. So Carl is a previous award winner, so for CodeSpec, and some of you have sort of studied the deck. We have all the decks recorded from previous years, and Carl's team won in, I forget the year, a couple of years ago, won our top prize, and so we've invited Carl back. And he also gets the longest commute award, because he drove from Pittsburgh to be here. Not today, I don't think. No, okay, all right. And I'm sure getting to meet some, reconnect with folks here in town, so that's really nice. Vanessa Lane, our next judge, is judging for the first time. Vanessa Lane is co-founder and COO of Better Place Studios, an Ann Arbor-based startup working with leading psychologists to create video games that are good for mental health without sacrificing any of the fun. She began her career as a middle school English language arts teacher and will always consider herself a teacher first and foremost. Outside of school, Vanessa is active in her local community as a Girl Scout leader and at her children's school, Angel Elementary. For fun, you can find her watching an NBA game with her husband or reading with her kids. And I just learned that you are launching your sort of major launch on Monday.
Yeah, so MVP launch is Monday.
MVP launch. Some of you know what this is. Minimum viable product launch on Monday, which is very exciting. Congrats on that. I can't wait to see it. And you get our new judge award. Thank you. Josh Nichols, friend of Cedar from long back now. Josh is CEO and founder of Crossbraining. Josh has taught for 20 years and approaches each lesson using project-based learning. Josh also sat on the MySTEM advisory board for the state of Michigan from 2017 to 2019. Josh launched an edtech company called Crossbraining in 2017 that focuses on digital storytelling, demonstrating proficiency and competency using video and narration and networking teachers. Josh, you get our throwback judge award because you were part of our first year 6 years ago. Thanks, Josh. Good to see you. Brenda Said-Wright, Director of Instruction and Intervention at Riverview Community Schools and owner of Great Lakes Educational Group. Great Lakes Educational Group believes that students should be prepared to meet their current educational needs as well as future challenges. Founded Great Lakes Education Group as a resource for parents and students, kindergarten through 12th grade, focusing on the learning and logic skills required for kids and young adults to perform well in school and ultimately reach their potential. Under Said-Wright's expert guidance, Great Lakes Education Group has been named Best Tutoring Center in Ann Arbor and Metro Detroit area 5 times. Our returning judge. Thank you, Brenda. Great to see you again. Wonderful. Our our judges have the hard work tonight. So the teams have practiced and developed their work over months and sometimes longer. But the judges have to make the decisions tonight, and so they'll do the hard work. But our teams, I'll introduce briefly the teams, and then could use my notes. I have the. Sorry, I had my. No, yes, thank you very much. I want to get names there. Thank you very much. So Math Myths, Shuishen Liu. And Math Myths leveraging the recent advantages of large language models, Team Math Myths aims to develop a joint storytelling application. The application offers children new opportunities to co-create fun, math-related stories with their storytelling partner, Math Myths, and engaging them in an exciting way. This is the order of the pitches tonight, by the way. So this is the Climate Chaos, Alina Kaser. Climate Chaos is an interactive educational board game for young teens. The game consists of the players learning the leading causes of climate warming and strategically applying practical solutions. We were really delighted to see an old school board game, which with some tech, believe me. Code Block, Chao Lin and Tara Dorje. CodeBlock is a mixed reality application that harnesses the power of immersive technology to teach foundational programming concepts to K-12 students. CodeBlock invites users to assemble interactive 3D code blocks and generate output in an immersive MR programming environment, effectively converting a child's room into a dynamic coding playground. String Theory, Toinu Reeves. String Theory, a 2D puzzle video game, trains users to apply the rules of logical inference and to solve formal logic proofs, increasing speed and accuracy in applying logic and solving logic proofs as users play out for their own enjoyment. Kids AI, Jessica Browning. As generative AI revolutionizes society, Kids AI endeavors to empower kids with essential skills. Our platform offers structured learning and critical evaluation tools to navigate AI responsibly. Join us in fostering a generation ready to thrive in the AI era. And hopefully you're starting to see why this is really an exciting thing, because we get to, these are just amazing ideas. So again, Elizabeth mentioned this, but when we do offer the awards and when the judges are deliberating, this is the structure they're using. We'll give a single Learning Lovers Prize of between $5,000 and $10,000, and then development awards to other teams that are deemed worthy. Okay, how'd I do? Okay, good. I can get out of your way now. So you'll see student pitches of roughly 7 minutes, and then a question and answer following directly from our judges. You'll see that repeated 5 times, and then the judges and I will leave, we'll deliberate, and you'll get a chance to actually ask the teams questions. So if you do have questions that you want to ask them, or words of encouragement, feedback, Darren will lead that discussion once the pitches are over. But with that, let me do some slide magic. And invite Shuishen to come on up. Great. You want to check if your mic's on?
Yeah. Can
Great.
everyone hear me? Okay, I cannot hear. I think my voice is the same without doing this microphone. If it's too loud, just let me know. Yeah. So I can start.
You can start. Darren will give you the time, 2 minutes and then 1 minute.
Okay.
Great.
Okay, hello everyone. Today I'm going to pitch MathMate, a joint storytelling application to learn mathematical language.
Good to get this out of the way early, right? Let's see if it works.
Okay, let me back up.
I think it's working now. All right.
Oh, okay.
Great.
All right, I will restart then, since I only said one sentence. Okay. Hello, everyone. Today I'm here to pitch MathMate, a joint storytelling application to learn mathematical language. And I'm Xue Chen. I love to work and help kids learn. That's why I taught before coming to Michigan. And I'm also very passionate about designing safe and educational tools for children. That's why I'm here in Michigan to further learn and do research on learning technologies. So I want to acknowledge that this project is an interdisciplinary collaboration project. So there are so many kids who know math is important because they can develop their problem-solving skills and logical thinking skill through learning mathematical language in a more comprehensible and tangible ways. However, they often find difficulty in understanding those abstract mathematical vocabularies such as estimate, abstract. And also they find difficulty in seeing those real-world application of those words. And Lily is one of the kids. So Lily, like other kids, love storytelling because one-on-one storytelling session not only can engage her with the storytelling, but also make it easy for her to understand those abstract words. But however, due to the large teacher-children ratio in the classroom, it is impractical to have one-on-one storytelling session on a large scale. So that's why we built our learning levers, MathMaze. So MathMaze not only bridges the gap between abstract mathematical language and engaging learning experience for children aged 4 to 8, it also transformed the limited one-on-one storytelling session to unlimited one-on-one storytelling session. What's unique about it, it's very accessible to children, and it also provides dynamic, interactive, and personalized learning experience. So we use this well-designed framework, question feedback scaffolding framework, to design our collaborative storytelling experience. And MathMaze is powered by GPT-4, the most advanced large language model at this stage. So by leveraging the capacity of GPT-4 and integrating this well-designed framework, MathMaze can generate questions to facilitate children's continuation of the story, and it also can continue the storyline based on the children's response. And MathMaze can also provide the scaffolding to the children with the further suggestion or follow-up questions. So MathMaze will be played out through this smart speaker. And if the child wants, they can pick one of their favorite plushie before the storytelling. And then they can hold this plushie and act out during the storytelling to further support their embodied learning. Now I'm going to show you how this MathMaze work. So this is so disappointing. Okay, so the child, before the storytelling start, the child will start with a warm-up session. The MathMaze will ask the child's name and the child's feeling for today and introduce this storytelling game. And then MathMaze will prompt the child to set up the character's name and the setting of this story. And then MathMaze will incorporate the children's response on the character and the setting to start to initiate the story plot. And then MathMaze will start to ask an open-ended question to the child to further elicit how the child wants the storyline to move forward.
Question. What will Purple do next on the frozen ocean that is half the size of the planet? And how will he maintain his speed equal to a spaceship?
And then the child will respond to this question.
There's a dragon and a huge sword and a huge shield. So it gets the dragon.
And then MathMaze will provide the feedback to the child.
Adding a dragon and a sword brings an exciting climax to our story.
And I just want to add one more point here. So this is not the case, but if the child indicate confusion, or for example, I don't know, or the child only said one or two words, actually MathMaze will ask follow-up question to further support children's learning. And then MathMaze will continue to build on this storyline based on the child's response.
Purple and Stellan could only estimate the size and power of the dragon before them. They also had to estimate the strength required to wield the huge sword against the dragon.
And lastly, MathMaze will explain those mathematical words within this context.
In this context, estimate refers to making an approximate judgment or calculation, often about the size or strength of something, which is exactly what Purple and Stellan had to do in their final challenge.
So we are so excited because kids learn mathematical vocabularies after doing the storytelling with MathMaze. And they also have very positive perception of this story co-creation experience. So when we look for the story application in the market, we did not find any AI-powered storytelling application focusing on teaching math vocabularies. And then when we compare MathMaze with other 4 top most popular AI-powered storytelling application, we found that MathMaze actually address some unfulfilled needs, such as generate adaptive questions, teach mathematical word, and build the storyline based on the child's response. So we also want to acknowledge that there's some limitation of our initial prototype. You may notice that some wording might be a little bit challenging for young children, and the MathMaze voice are not very as natural as humans' voice, and the talking speed might be a little bit fast for younger children. So to address those limitations, our next step is to further collaborate with teachers, parents, and children to further develop MathMaze and continue to do the usability test with the updated version of MathMaze. And now MathMaze only support English language, but ultimately we also want to add robust feature to support learning of children with diverse culture and linguistic background. So to fulfill this goal, we are seeking 10,000 in total to support co-design with parents, children, teacher, incorporate additional feature to support children with diverse background, and continue to do the usability test with the updated version of MathMaze. So that's why we are so excited. That's why we are here to share MathMaze with everyone and to let kids to learn with fun. Thank you.
We'll just do it like this. This works. This is a great idea. Math vocabulary is something that's very challenging for students, we notice. Have you looked at how long a student will stay engaged with the actual storytelling going back and forth per age?
Yes, I think I understand your question correctly. Yeah, so during our user test study, each child will do 6 rounds. MathMaze and the child will do like 6 rounds each to share what they want to add to the storyline. So that's take about like 7 to 8 minutes. But we found that based on our observation for the older kids, maybe in the upper age, like 6, 7, or 8, they could see there like definitely more compared with the younger children. For example, if they are like 4-year-old, yeah, sometimes because we also have the recording, we will notice that actually they like maybe look at somewhere else. But what interesting is, I think this is where the creativity or the surprising part of young children is. Like sometimes if we just look at a video, oh, this young kid is look around here. So did this kid really listen when MathMaze talk? Actually, they did, because once the MathMaze asked a question to ask the children, oh, what do you want to add on? And actually they could like come up with something actually is relevant to the question. And then the storyline can continue to move forward. I hope I answered your question.
You did, thank you.
Okay, thank you.
So great idea. I love the stories and the math being brought together. I had a question about both how you plan to involve parents and also if you thought about any tangible outcome, knowing that generative AI can generate images. Have you thought about a possible book at the end for them to keep track of, a way for them to keep track of the interaction that they had?
Well, that's a wonderful and great question. Yes. So in terms of the parents' rule, so let's imagine if this child at home and then they are doing this storytelling with this smart speaker. I think we can think about how parents participate in this process from 3 different aspects. First, the parents could be a learner. I'm saying that because I grew up with my grandparents, although in this context, grandparents. But I grew up, I did not do any storytelling activities because my grandparents, they don't know how to do this with the child and also how to ask questions. So one way is, I think, parents by watching or observing how mathmates ask questions, the parents actually could learn like the strategies, like how you could ask children questions during the storytelling. And then the second rule is they are the observers, but they are also the safeguard. Means that, we have been thinking about the safety part of this generative AI. So although we did a lot of work to make this accessible and safe for children, but I think parents, they are also adults. They can know, to protect the children from listen to any inappropriate stuff. Although we already try our best to avoid this situation happen, and I think it won't happen. But yeah, so yeah. And then for the second part of your question about the tangible outcome, yes. So as you can see now, the children do this storytelling through this smart speaker, but eventually we're also wondering, maybe after a couple of years or even a couple of months, what if the generative AI also can create those visual support for the children along the way, not only by listening, but also can see on the screen, what's happening in this storyline. Yeah, I think that's one thing we thought about. Yeah.
Just as a quick follow-up to that, have you thought about more gamification with this product? Are there ways that the generative AI could inspire more active activities for the kids, especially the younger ones who might struggle to just sit still and listen to a story?
Yeah, that's a also good feature. Yeah, I would say yes. I think our team is pretty open to this idea, but it just in this stage we haven't tried to incorporate this gamification feature to what we have right now. But for sure, will be a good direction to go in the future. Yeah, thank you for asking this.
Who is the purchaser? Who purchases this?
This MathMate?
Who's writing the check?
Great question. The short answer is our partnership. Yeah, so our goal is to use MathMate, there's two part. It costs money. One is to buy smart speaker. But of course, if you have smart speaker already, you don't have to spend this money. But then another part is the cost of GPT-4 subscription. But what we have been doing, our plan is that we will have more partnership with different organizations and institutions so that we could cover the users' cost of those subscription fee of using GPT-4. And also, eventually we were thinking about this, Coursera, sometimes you want to enroll this class, but you can apply for scholarship or funding. So that's also another avenue that we could use is besides distribute the free speaker or cover the GPT-4 subscription, but we can also open the opportunities for parents, teacher to apply for money to cover the cost of this. Yeah.
Thank you. Thank you very much.
Thank you.
Thank you for going first, Rishen. It's always good to. I feel like we always settle in after that first one. So thank you for going first. More slide magic coming in, and we'll get Alina up here. Those are great questions. Darren and I both you sort of blew our mind with the book, the book question. I feel like. Okay. Great.
Hi, everyone. Today I'll be presenting Climate Chaos. It's an interactive board game to enhance global warming education. My name is Alina Kesser. I'm a first year's master's student in UX research and design, and I'm very passionate about designing educational technologies to enhance interactive learning. And the challenge that Climate Chaos addresses is global warming. And the lack of awareness of global warming, it has reflected a sharp increase in the harmful effects on the environment. And the current teaching methodologies, they're still old school with non-experiential learning. And you can see from the graph here how the global temperatures, they've drastically increased. And the top 3 warmest years have been 2016, 2020, and 2023. And very likely that this year will be on the list. So I narrowed down the causes of global warming to 6 main causes. We have overconsumption, industrial farming, burning of fossil fuels, deforestation, waste disposal, and transportation. So the question is, how can we create a learning tool to enhance global warming education to instill environmental responsibility within young teens? But why even focus on young teens? Well, at that age, they're absorbing information to help them make informed decisions. This can help instill environmental responsibility and further develop personal connections to climate change solutions. So the Harvard Graduate School of Education, they conducted a research study with 1,500 science teachers who said that they spent only 0 to 2 hours a year of climate change education, and a quarter of all 15 to 17-year-olds in the US, they reject the idea that climate change is even a crisis. And the Michigan Science Standards, they say that when students do science, that's when the learning of the content becomes more meaningful. So towards the end of my research phase, I developed 3 personas of a student, parent, and teacher, and did some empathy mapping and made an affinity diagram. This is my ideation and development phase. I took inspiration from games like Battleship and Uno to develop the gameplay and the form. So this is the final solution, Climate Chaos. It's a 2 to 4 player interactive board game to help the players learn the leading causes of global warming, strategically apply practical solutions, and receive feedback through an interactive temperature meter. So how does the game work? You begin by opening the 4 flaps of the 4 flaps of 4 boards. Each flap or each board is for 1 player. And you begin by, 1 player fans out these cause cards to all the players, and everyone picks a card at random. The cards are basically the 6 main causes of global warming that I mentioned earlier. So everyone takes a card and inserts it into their board. So every card is equipped with an RFID tag, and all the boards have an RFID sensor. So the board knows what card is being inserted and when the card is being inserted. So let's say I have the deforestation card. I'll insert it into my board, and the board will be activated, and the red lights will turn on. It's a series of red LEDs, and it symbolizes a thermometer. So the objective of the game is you need to be the first player to lower your temperature. And you do that by applying the correct solutions that match with your cause card. So if I have deforestation inserted into my board, my objective is I need to solve for deforestation. And I do that by applying the correct solutions. And the solutions come in the form of coins, solution coins. And so each player has 3 solution coins, and you're supposed to keep those coins private. You can't show it to other players. And when it's my turn, I will draw a 4th coin. So with these 4 coins in my hand, I need to see, are any of these coins the solution to the cause card that's inserted into my board? Are any of these the solution to the deforestation card? So if I do think the coin is a solution, I will place it on my board. And all of the coins have been programmed to their respective cause cards, so the board knows if it's the solution or not. So I will place the coin on the board, and the board will provide me feedback. So if it is actually the solution, the temperature will decrease. So I know, okay, this is the solution to deforestation. If it's not the solution, then the temperature will increase. So this is how Climate Chaos is enhancing visual learning. And if I don't think any of the 4 coins are the solution, I will just discard 1 coin into the discard area, because I need to keep 3 coins in my hands at all times. But I need to be very careful, because if I discard a coin, the player after me, they can draw the coin that I just discarded, and they can use it at their own advantage and lower their temperature and possibly win the game. So I don't only need to keep an eye on my board, I need to keep an eye on the other players as well. There's also a coin, the strike coin, that red coin over there. This is very similar to the draw 4 card in Uno. So if I see a player is about to win, that their temperature is very low, I'm gonna use this coin if I have it. I'm gonna place it on my board, and it will increase the temperature for all players. And this gives me some leverage and some thinking time to use some other strategy to win the game. Yeah. So these are the cause cards. These are all the solution coins. They're very simple. They have an icon and a short description. There are different types of solution coins. There's a direct solution and an indirect solution. They affect the temperature differently. And so how does Climate Chaos enhance learning? It's a very interactive game. You have an interactive temperature meter, which provides you feedback depending on the temperature levels. And you're not just focused on your game, you're interacting with other players as well, because you need to see who is about to win, what strategies you need to use. So this enhances social skills. It also enhances flexible thinking as you're learning to use different strategies to win. You learn to make decisions, solve problems, deal with mistakes, and it's a competitive game, so it encourages players to strive for excellence and try to win the game. These are just some close-up renders, 3D renders of the game. A very short snippet of my 3D animation. We can watch this later if we have time. So I conducted usability testing with 24 middle school students, and I divided them into 2 groups. So group A, they filled a questionnaire after playing Climate Chaos and after listening to a very traditional lecture that they're used to. And group B filled the questionnaire after only listening to the lecture. They did not play the game. And I made sure that the questionnaire was in line with both the game and the lecture to avoid any type of bias. And the results of that were Group A retained more information and performed better on the questionnaire than Group B. And the students described the game as fun, entertaining, and challenging. And the teacher said that it's a helpful educational tool and it can result in an impactful learning experience. So I conducted 4 interviews, 3 with middle school science teachers and 1 with the founder and CEO of a startup gaming company in Pakistan. And the key insights from that was it's difficult to engage students at an individual level. They all manage a Go Green Club where they teach the 3 R's, so reduce, reuse, recycle. They all offer formal lectures with visual elements, but again, that's not really engaging enough. They all encourage planting, and most of the solutions that the teachers teach, they are not practical enough for this type of age group. And lastly, the game should have a wow factor to stand out from the rest of the market. So with the Learning Lovers prize funding, I do plan to create a fully functioning prototype to commercially sell this game or idea to gaming companies, middle schools, or maybe even individuals. And it can further be implemented into a mobile app to increase, to broaden the audience and increase its flexibility. And when talking about sustainability, the cost cards, they can be made from recycled paper. The board itself can be made from recycled plastic. And instead of using disposable batteries, rechargeable batteries can be used. So yeah, this is the end of my presentation. Thank you so much for listening, and I hope you enjoy learning about Climate Chaos. You can scan these QR codes if you want to watch the 3D animation or check out more details on my portfolio. Thank you.
You mentioned that there's a lecture that was given. Who provides that lecture? Like, who provides the materials for that lecture?
So yeah, we went to a middle school and we designed a lecture with teachers, and we made sure that the content of the lecture was aligned with the content of the game. So there wasn't new content in the lecture, there wasn't any new content in the game. So we made sure that the content was the same. So the teacher, she taught a lecture the way that she normally does, and this is very normal for the kids because that's how they usually learn in the classrooms. And then after that, they played the game, and then they filled out the questionnaire.
So the lecture comes with the
No.
the
This
game?
was just for comparing if the lecture itself is impactful enough or not. So there were 2 groups, Group A and Group B. And we just wanted to see if the lecture itself was impactful. And so the Group A, they listened to the lecture and they played the game, but the Group B only listened to the lecture. And Group A performed better in the questionnaire.
Thank you.
Yeah.
So I just have a question about the wow factor. Were the people who were suggesting that there needs to be a wow factor, were they saying that your game lacked that, or did your game provide the wow factor?
No. So I interviewed a CEO and founder of a startup gaming company. She said that the game should have a wow factor. So that's why I incorporated the interactive temperature meter, so it can provide you feedback on the actions that you're doing in the game.
And I mean, this is just kind of speculative, but I mean, did it work?
Yeah, it worked. So this is the functional prototype. It was very partially functional. Only a few coins were functional. So I worked with an engineer and we programmed 2 coins to 1 card just to show that if I'm placing the solution on the board, the temperature is decreasing, 1 LED is turning off, and if I'm not placing the correct solution, then the LED is turning on, and so temperature is increasing.
You mentioned that you talked to different middle school teachers, and they spend very little time on global warming education throughout the year. How do you plan on educating them to spend more time in order to play a game like this? Because I would assume instructionally they would teach about it first. They would probably do some activities or labs with it before they would go ahead and play the game.
Yeah. So the thing with traditional formal lectures is they're not engaging enough, and that's not bad. I mean, formal lectures, they are very in-depth, and it's important to learn about global warming in depth. So the teachers can teach the lecture, but this can be used to enhance the learning experience. So if they teach a lecture on deforestation, but the game is not only teaching about deforestation, it's teaching about waste disposal, burning of fossil fuels. So this can be used towards the end to strengthen the concepts of the students. And when I was doing usability testing, it was I observed the students playing, and it sparked a lot of meaningful conversations. They're like, oh, how is this a solution to this cause? And they were just talking amongst themselves, and that was very interesting to see.
What is the cost of one kit for those 4 players?
Yeah, so since this is not a traditional board game, it does have technology like RFID tags and sensors, microcontrollers, LEDs, and batteries. It will be more expensive than a traditional board game. I'm not sure how much each of these elements they cost, but it can be, to make the functional prototype, it can cost $10,000 or more, $10,000 to $15,000. Yeah.
I'm just dying to know, do you have any plans for like a digital version of this?
Yeah, I did plan on a digital version. Before even designing this, I thought, why don't I just make an app? But I made this after COVID, and a lot of parents were concerned that their kids are just glued to the screen. So that's why I first made a non-digital version without any screen. But it can be implemented further into a mobile app, so everyone can play it anywhere on their phones.
In terms of benchmarking against any other, did you find anything similar?
Surprisingly, I did not find anything similar. There are other board games that teach climate change, but none of them had an interactive element to provide immediate feedback on the player's actions, because they're all just traditional board games. None of them had any technology implemented in it. So this, through the temperature meter, it provides immediate feedback.
Any other questions?
I have to ask one more question.
Please.
Sorry, I don't mean to monopolize, but so what if you're in a classroom and you get one kid who's really reluctant they just don't think climate change is a problem? Are they going to have fun playing this, or are there other ways for them to have fun?
That's a good question. I try to make sure that the game is more fun rather than the students see it as a fun game rather than an educational game. So the students that I did the usability testing with, there was actually one student. She's like, I don't want to play an educational game. I don't want to learn anything. But then when she saw other students playing it, she's like, okay, you know what? Maybe I'll play as well. So she did actually enjoy it. She was reluctant at first, but when she saw other students enjoying it, because it's a game, and you're just learning, as well. So she did end up enjoying as well.
Thank you. Thank you so much, Lena.
All right. Hi, everyone. Thank you for being here today. My name is Tara.
And I'm Chow.
And we're both master's students in the School of Information, studying user-centered agile development and UX research and design. We're thrilled to be able to share some of our work in the field of mixed reality and to introduce our application CodeBlock to you all this afternoon. So educators have long grappled with this question of how to make coding education more accessible and engaging for young students. According to the VARC model, we know that some children prefer reading or writing in their instruction, while others require images and diagrams to truly ingrain some topics. Yet another subset of students can only perform their best when provided with direct hands-on interaction opportunities to ingrain new concepts. So given this reality, Qiao and I, sorry, is this a given issue or is it? It's okay. Okay. So given this reality, Qiao and I identified a series of limitations in the realm of early coding education. Despite the number of educational resources available today to young novice programmers, current instructional approaches overwhelmingly force students into stationary learning environments and confine them to two-dimensional screen-based interactions. Qiao and I soon recognized how traditional text-based programming languages and even block-based visual programming languages explicitly designed to teach coding to children fell short in their ability to deliver embodied learning experiences to those students with more kinesthetically oriented and multimodal learning styles. We're here today to help ensure design for all when it comes to early coding education. Our team has identified mixed reality, or MR technology, as the ideal avenue through which to accommodate a diversity of learning styles. We aim to leverage MR as an instructional technology and to facilitate immersive embodied learning experiences in which students can learn to code through play and intuitive interactions.
We're excited to introduce CodeBlock. It's a mixed reality application harnesses the power of MR technologies to teach young users about concepts of fundamental programming. Our applications enable users to build programs with 3D code blocks by using natural hand gestures and render the outputs in their own environment. Before we introduce these applications, there are some concepts we would like to address. First is object blocks. It functions like variables. It's using the MR technology, scene understandings, and the semantic tags to transform the object that's into a programmable object blocks for users to use. So users can incorporate those object blocks in their own programs. Second is target blocks. It reflects the programmed outputs. So user can select a virtual object such as a rabbit or a virtual car to act as the agents of their programs and then carry out the actions. And just as in traditional programming, users have access to functions such as change colors, turn around, or move forward. Once users compose their code and execute it with their target objects, the object will respond accordingly to the sequence of the code. Here are some examples just to show you how it looks by connecting a target block and a function block together. So how does the programming coding experiences in CodeBlock's Playground look like? So when you launch the program, the systems will query what object is currently available in your room, and then it will generate object blocks for you to use. You then start to compose the code by grabbing and stacking the code block together. And once you have completed the code and compiled the code, you drag those code blocks onto the target, and it will respond accordingly in your own environment. So using those components, Alex, a 12-year-old CodeBlock user, could quickly build a program that sets a virtual car to navigate on the perimeter of his living rooms and avoiding objects such as the furnitures or plants. And similarly, Emily, a 15-year-old CodeBlock user, will be able to reinforce lessons from her current intro to programming classes using concepts such as if-then-else statements. So her code might look like, if the rabbit is in a certain distance of the bed, it jumps. Addition to our playgrounds in CodeBlocks, there are 3 modules to enhance users' learning. One is lesson modules that guide the users with the structured learning path, and missions modules to quest the users with gamified learning experiences. And then the community hub is where it provides a space for users to share their programs and connect with others.
So CodeBlock is informed by studies on the educational benefits of MR technology. Research has highlighted the strengths of MR and embodied learning, particularly for children, illustrating how integrating physical movement into instruction can significantly enhance learning outcomes. However, if we look at the market today, we see that most MR experiences skew toward pure entertainment. There are limited MR apps focused on learning, and when it comes to MR for coding education, there really are no direct competitors operating in our domain.
So this CodeBlock prototype was first developed during earlier this year during MIT Reality Hack. There were about 60 users who have tested out our MVP, and most of them are experienced designers, developers, and researchers in the XR domain. And here we have include some of their feedbacks just to show you how those professionals saw the CodeBlock's features to influence the field.
CodeBlock is being developed in 3 phases, which include the launch of our app on the Meta Quest Store, and eventually we hope for the full version to be made available with the Meta Quest Plus subscription. If we were to consider even a 1% adoption rate for CodeBlock among active Meta Quest users, these are some of the numbers we could then expect in terms of sales and revenue.
So our team is prepared to build the beta versions of CodeBlocks, and we have already recruited a computer science student to join our team, and also we have onboarded Professor Michael Lebling. He is an expert researcher in the field of XR. He will mentor us forward, and our goal is to build the first phase of CodeBlocks and then launch it on Meta Quest Store in the end of the year.
Any funds received at this stage would directly support the development of the application features we've described today. We truly feel that CodeBlock is arriving at an important juncture in the world of immersive technology. Our application is uniquely positioned to introduce an entirely new dimension to existing visual programming paradigms. By embracing MR, our application will train the next generation of engineers and leaders to navigate the coming era of spatial computing. We invite you all to join us in our quest to propel coding education into mixed reality. Thank you, and we welcome your questions.
I love the immersion. I'm curious about the community hub and if you thought about multiple learners at all.
Okay, so with current Meta Quest SDK, it's actually possible. Okay, to answer that question, there are 2 ways. They are possible to do multiplayer in that headset, saying like player A and player B, they can all work on one code at a time. And also with the community hub, it's more like a platform that I can show you, like I have built this code that's enable this rabbit to jump on the bed, and I can show how I build this code, and someone on that platform can access to that code and learn from their experiences and try to build that in their own environment as well. Yeah.
Would it be possible for the 2 kids to be able to work on the exact same code in different locations? Collaborating?
Okay. I think for multiplayers mode to be utilized, they have to be in the same room, meaning, but they are able to see the same virtual contents at the same time. But if one kid is at maybe classroom A and another kid is at classroom B, then this, I would say possible, but with so far the SDK, which is the software development kit, will be really hard for engineer to achieve that for this current state.
Have you thought about a student building a code and then like another student trying to figure out the code that they used?
I think for that example, you see like maybe I watch this YouTube and this designer build this cool VR experiences. I would try to figure out how to achieve that. I think that would be a similar experiences. So I think in terms of that, let's say the community hub, we have a galleries or just a bunch of videos that users built, and then I can check out their results. Instead of just go straight to the code, yeah, I can learn, like try to figure out what's the logic behind it. And even at the end, I couldn't figure it out, I can check out their code. Yeah.
Okay, thank you.
I'm also wondering about, it just occurred to me, it blew my mind a little to think about this, but using code block to create like a remote control that actually works with your TV, or something that actually works to make your light a smart light so that it turns on and off, or interacting with the actual things in your environment, and ways of really programming those things seem like it could expand that way as well.
I think I saw that example somewhere earlier this year. Things like to have these IoT things, because each application in your room, you have their IP addresses. So to do that is actually possible, but that is not the scope in our CodeBlocks project still, to be honest.
Yeah, but I think that does speak to all the potential there, and why the one of the professors we're working with, or who's serving as our mentor, was so excited about this, even beyond just the scope of programming education. Yeah.
I think I would follow that up very quickly with cost. Have you thought about cost? I know that at least, is it Apple's one that just came out is about, is it 10? Is it 5,000?
We actually have that direct information, if we can.
Sorry, there are just something in case you guys. I'll say, yeah.
Yeah, so yes, 1,800. Mm-hmm.
Yeah, I do aware of the affordabilities varies from family to families, and right now for class 3 is about $500. But what the information I've been getting is that Meta is currently working on a 3S versions that is not announced publicly. They are looking at the cost to cut the cost in half to make it more accessible for the users. Yeah.
And all of our development goals are currently focused toward achieving a full version of our app for the MetaQuest store at this time.
I just have a user acquisition question. So I know you've got an SDK coming, and maybe you could clarify what's coming out in the first round. I think it's like the cheaper version. Was it like $5.99 or something? How are you going to keep people engaged in this product? Because you can only make a rabbit go around a room so many times. Mm-hmm. So is there other content? I think you said there's lessons and there's I was wondering if you could clarify what's in phase 1 a little bit more.
Okay, so in phase 1, what we want to achieve is to provide the user ability to really code with room objects. Yeah, it serves as just an environment. There is no instruction or something. Maybe just a little bit prompt to the user how to utilize those functionalities. So in phase 2, we have missions which utilizing gamify experiences to task the children okay, now try to write a code that make these cards navigate around your room without really hitting the wall, things like that. And for Quest phase 3, we're looking at the social aspects of these possibilities to let users to really build their communities in this on these applications. And in terms of revenue-wise, I think so when we have phase 1, we can sell it at the point, and then when we have phase 2 and phase 3, we will sell it as version 2 and version 3. And another income stream for our application is that. Sorry, let me find this real quick. Yeah, here. So my idea is at the playgrounds, they will have some primitive 3D assets, such as a rabbit or toy car that's easy for us to provide. But then there is a possibility that we can collaborate with 3D artists, and then they can sell their artworks and then become their targets. So make the whole learning environment or the asset store more fun to have. Yeah.
More question? One burning question? Okay. Thank you so much.
Thank you.
Pass off your mics and we'll do our slide magic. You ready, Toinu? Great.
Hello. Okay. Thank you. Thank you, everyone. So this is string theory. We're hoping to unlock the power of playful logic. So imagine that we can, sorry about that.
Okay, should be good now.
Imagine that we can improve standardized test scores, academic performance. Is it? academic performance in subjects, especially STEM, college and career readiness, all while closing racial, gender, and rural achievement gaps, all while having children to just play a video game like, I think this is Tetris. Now that's a pretty brazen statement, but before simply dismissing it, allow me to present our logic, literally. So logic is the God particle of the cognitive domain. Every conclusion, every inference, every evaluation, decision that we make is based upon logic. Our standardized tests are based upon logic. The LSAT is a test of pure logic. The math portions of the GMAT, GRE, and SAT are all testing mathematical logic. Even the reading comprehension portions require you to understand logical structure of a passage and to make logical inferences based on the information in the passages. Our academic subjects. All of mathematics and computer sciences are strictly logical processes. Scientific reasoning, including social science, is only a subset of logical reasoning. Musical, poetic, and grammatical structures as well are logical constructs. And persuasive arguments in the humanities, language arts, and every profession, from law to business, are based upon ethos, pathos, and of course, logos, logic. So despite being so critical to learning, logical reasoning is somehow overlooked in our curricula. It's somehow expected that students will implicitly learn this type of a skill set. We believe, however, that developing formal logic skills is the skeleton key to unlocking improvements in all academic subjects in all professions. So what makes logic so powerful? Let's consider the following argument. If it rains, then the grass will get wet. It did not rain, so therefore what can we conclude? Naturally, that the grass did not get wet. Well, this is actually a logical fallacy that people often make. Something other than rain can cause the grass to get wet, such as a sprinkler system. So sound logic allows us to reach our destination, the conclusion, fast, precisely, whereas logical errors slow us down and could even leave us lost. Math and computer science are so effective because they make logical errors clear. This is perhaps why people hate mathematics so much. So when we look at formal logic is what I consider to be the algebra of arguments. So just as algebra allows us to symbolically represent mathematical statements for ease of evaluation, we can take an argument like Darwin's one long argument and symbolically represent it in a logic format for ease of evaluation. Now, we're not going to be able to teach children logic that looks like this, that run away from us. But we can teach them gamified formal logic that looks like this. Professor Nass taught us that every game has a certain logic behind it. Right now, we even talk about the sports IQ. The more a player plays a game and is exposed to more scenarios, she gains mastery over the moves in that game. And she learns how to identify the optimal strategy with more speed and accuracy. The problem is that games like Tetris, for example, have game-specific logic. So the logic that you develop playing Tetris over and over again will not translate into other areas such as mathematics, at least not yet. So string theory is a 2D puzzle video game that allows users to apply the rules of logical inference and to solve formal logic proofs. Each move in the game corresponds to one of the 10 rules of formal logic. So by playing the video game repeatedly, players will gain mastery over the rules of formal logic and solving formal logic proofs with increasing speed and accuracy. The logic learned in playing string theory is universal. It's formal logic, the God particle, the skeleton key. In string theory, players will form emoji strings by joining emojis together using the different colored hearts. Each emoji represents a logical statement. So for example, in a history class, Washington crosses the Delaware. While each colored heart represents a different logical operator, and that assembles and disassembles the strings according to a specific rule of logic. So the process of starting with a set of initial strings, which in the formal logic is our propositions, our initial propositions, and using the heart operators to assemble and disassemble strings and to gain more strings is precisely a formal logic proof. So on the right-hand side is something that you will find here at the University of Michigan in a classroom. On the left-hand side is the same proof that we would do in string theory. So string theory has 4 panels to it. It starts with a player taking a string from the strings panel, dragging it into the sandbox where operations are performed on the strings. Once an operation is selected, it demonstrates what happens within the operations. And then you can see here that when she selects this operator, 2 new strings are formed, and they now populate in the strings panel. She can also access the formal proof by looking at the traditional proof format by looking at the proof panel. So string theory's graphical interface eliminates logic syntax, making it more easy and accessible for learners of all ages. With 99% of boys, 94% of girls playing video games, we think that string theory can be a game changer. Every child, we'll be able to access every child with this critical, crucial STEM skill, building skill, closing race and gender attainment gaps, reaching children in rural areas without highly trained STEM teachers. It's been premised on quite a bit of research that employing visual programming and agent-based modeling can help develop computational thinking skills that are correlated to curricula. Our next step is to build the game out over the summer, and we hope to, the Detroit Country Day School has agreed to host our research evaluation this fall, and we're working with the Detroit Public School System as well to get permission at their schools as well. We have a team, I think a wonderful team here. My background is I'm also a player and coach in K-12 logic game competitions. We have a very strong technology officer who's worked in learning analytics. And we have some guidance and mentorship from individuals in the tech sector as well. I think I'm going over time here, so I can just wrap it up to take one or 2 more minutes. So how do we plan to market this and monetize it? So you can take any examination or any question can be taken from a word and established into its into its logical form, and that logical form can be translated into string theory, the game itself. We believe this is going to be a preparation support tool for the LSAT, GMAT math, coursework in mathematics and computer science, and even helping with persuasive writing, persuasive arguments. We plan to market to schools with a freemium model, with an instructor portal, and also to parents and students with an online subscription that has these following features as well. So I'll end the opening here, and hopefully I can get the rest of the slides and some of the questions you may ask.
So I guess I'll start with what's the onboarding process like in order for people to learn how to use it and help other people use it?
So the games, we hope for the game to be completely self-contained. So the tutorial itself will walk players through the operations and how to play it.
Okay.
So the idea is that you're going to take it this is targeted for K through 12. So you can imagine, like for example, chess. You have kindergarten students will also learn chess, but at a very basic level. So you start with the very basic levels of the moves. You add more and more complexity to it, and by adding the complexity, every time they get to a certain level, they'll have different challenges that they can pass. And after they pass those challenges, they can go to the next level, and it kind of unlocks it for them to learn the next operator, and so on and so forth.
How might this look in a school setting? So when we're thinking about, I guess, where it would take place in a school setting, I'm not tying it to actual standards. Can you share a little bit about how you might see it being used in a school setting?
Sure, absolutely.
Thank you.
So ideally, we're hoping for the game to be as self-contained as possible. So we want the game to be something that, for example, children parents who often use the smartphone or their devices as a babysitter, that they can give it to the child to play and to learn, develop this skill set. However, we do believe that we can incorporate it into a classroom, particularly looking at mathematics and computer science classes. So, for example, propositional logic is a required course for all computer science classes. Also, you have Euclidean geometry, which you'll see on the SAT math portions as well. For example, you may see a question like, given the parallel line and the transversal, prove that these two angles are opposite, that these two angles are equal. So those are the things that you can translate directly into a math format and have those same questions. answered within the game itself. So the game itself can become the assessment. So you can program all of your questions into the game, have the children simply play the game to solve the questions, either as homework or as assessments.
How has the player testing looked so far when you've tested it?
So we haven't actually built it out and tested it yet. We're hoping to build it out over the summer and test it coming up this fall.
Can this be done on any device?
Yes, we're hoping to have it on every device. Yeah.
And I don't know if I saw it. What is the cost?
So we're expecting for the software itself, the game to be free downloads. We're hoping for subscriptions to be given through the personal individual subscriptions for children to go into the collaboration rooms, have tournaments, challenge competitions where they can create puzzles, and I can create a puzzle and challenge you to solve the puzzle. And I can create my own theorems within the game. So for example, the rule that says repeat, that P implies P, doesn't exist actually in formal logic. You have to prove that. Once you prove that, that becomes a theorem. So those can all be done on the platform. The platform subscription, we're looking at somewhere around $10 per month for the individual subscriptions. And then for the institution, we're looking at providing a staggered model for, depending on the size of the school district itself. So the idea is we're hoping to make this as accessible as possible to disadvantaged populations, students from disadvantaged population segments.
And where you say you track and monitor student progress, can you explain that a little bit?
Yeah, so for example, so this is kind of based off of my competition, my work and my coaching material as a coach. And so the thing is that each child is learning differently when it comes to logic. So some students may need to, repeat this particular field. So I may want to program these, a set of questions. So for example, let's out of the 10 different rules. First of all, there's a curriculum of progression. So you start with the very basic rules. Then with the basic rules, you add more and more complexity by just having those repeated several times. Then you add the higher level rules, it adds a second level of complexity. So based on that entire curricula, I can select different problems, and those can be generated within the game itself.
Does that all tie back to like the test, like the LSAT?
Right.
So that's getting you, if you do X, Y, and Z, you should be able to correlate that with when they do take some of those tests to determine if they are actually getting better at their logic.
Right. So I think there are two different questions you're asking. If you're asking within the classroom, we're not preparing like this type of LSAT, SAT for classroom. That's going to be more for like students who want to develop their skill set separately. So let's say, for example, for a teacher in a classroom that's teaching computer science, that they want to build their skill set for their students to do formal logic, they can have their curriculum according to the curriculum. They can have them test their ability to do different problems. So as part of the tracking, yes, you want to be able to track and say, okay, how many problems have they solved correctly? How much time is it taking them to solve those problems? All that you can monitor and identify. The idea is you want to have like an individualized plan for each student. So where is that particular student having difficulty, and being able to program that? Where is, what kind of support can we provide for that student to increase their students' logic skills?
Thank you.
Okay.
So who would be designing the individualized instruction for the student?
If you're talking about inside the classroom, that would be the teacher. But for the online version, for example, the player would have his own or his or her own history of courses. Of what they've completed, how many puzzles they've solved, what those different puzzles are, the complexity of those puzzles. They would have their own level of their own profile or whatever. Based on that, they can select more and more problems to help strengthen these skills and so on and so forth.
Thank you.
Thank you.
Thank you. Thank you, Tony. Excellent. Our last presenter, Jessica. All right, take it away.
All right. Good afternoon. I am so excited to be here today to talk to you guys about the importance of generative AI literacy. My name is Jessica Browning, and I am the designer and developer of Kids AI. I am currently a graduate student in the School of Information and the School of Education, and this is my board of advisors. They offered me insights and feedback throughout this process. I want to start with a quote from Victor Lee at Stanford University. I like to think of AI literacy as being akin to driver's ed. We've got a powerful tool that can be a great asset, but it can also be dangerous. We want students to learn how to use it responsibly. Generative AI is growing very quickly. In fact, ChatGPT is the fastest growing consumer app of all time. In just 2 months, it reached 100 million monthly users. For some context, it took TikTok 9 months and Instagram 2.5 years to reach that same metric. You can see here that the large portion of the population is using generative AI. Not only are they using it, but 52% of Gen Z reported trusting generative AI to help them make informed decisions in their lives. Education is no exception, with nearly half of high schoolers already reporting having tried generative AI. Unfortunately, we are also already seeing a divide in which students have access. When looking at ACT scores, over half of the top scoring students have already used generative AI, while only about a third of the bottom scoring students have done the same. This is statistically very significant and demonstrates just how important it is to provide equitable access for students to learn about generative AI. So this is the problem that I aim to address. How can we provide access for students to learn about this technology safely, equitably, and effectively? And this is where Kids AI comes in, a mobile-friendly website with a 3-part approach to teaching K-12 students generative AI literacy. I want students to learn what generative AI is and how it works, to create prompts and practice using the technology effectively, and to critique outputs and understand the implications of using this technology. There are a few existing solutions, however, a majority are targeted at teachers rather than students. Additionally, while there are products that teach about AI and those that use AI, there are none that offer a combination of the two, allowing students to learn and apply their skills in one place. Here are some additional challenges I found. Notably, that many of the solutions for students are targeted at those with strong technical backgrounds, further demonstrating that divide in who has access that I brought up earlier. Additionally, none of these tools ask students to think critically about the responses that they are receiving. This is a huge gap, as critical thinking is a key component to information literacy. I did get the chance to speak with several K-12 educators, and they see a lot of potential with Kids AI. They view incorporating generative AI into their classrooms as an opportunity to enhance and personalize their students' education and to engage their students in higher order thinking. The reality is they know their students are going to use these tools either way, so they want to be able to provide a safe space for them to learn about it and practice using the technology. There are some concerns that the teachers did bring up, and these are all very valid concerns. I have addressed them in the design of my product, which you're gonna see in a second. There it is. Okay, and so in addition to my research, I went one step further and created a prototype, which I am excited to show you guys right now. This is the homepage of the website. And this is the create page for a high schooler. So they get to use ChatGPT, but with a front end designed with students in mind. Each of these options is targeted at a best use case for education based on my research and my interviews. The students still have the option to create their own prompt if they want to, but it's not presented front and center like it is in ChatGPT. Once one of these options is selected, the students will receive a guided walkthrough of how to create a prompt to effectively approach each of these things. So it'll scaffold their understanding of effective prompting. While I will start with high schoolers because I think the need is more pressing there, I hope to expand to younger learners in the future. So this is an example of what the interface would look like for an elementary schooler. I don't know where it wants me to aim. Okay, there we go. So, and then this would be the critique page. So this is where students will learn how to critique the responses they are receiving from generative AI in several key areas. Once they do that, they can put their skills to the test and do a guided walkthrough critiquing different prompt and response pairings. These will be selected by me and based on the most likely issues they are going to run into. So you can see this example here. This is actually something I got from using ChatGPT. I asked it for 2 doctors on their lunch break. You can see every single person here is white. Only 1 woman is pictured. So there are a lot of issues and implications that come with using generative AI. There will be a free version. Like I said, equitable access is really important to me. So I want the platform to be available for everyone to use for free. There would be a paid individual account that would offer more access to the ChatGPT tool, since that is charged by token. There would be a charge for using it more often than the free package. And then there would be paid education, which would provide customized curriculum, professional support for the teachers, and overall support for the school. With the $10,000 Learning Lever Prize, I will design and develop the website, get it hosted, design and create the curriculum that will be hosted on the website, and also get it into the hands of students to start testing. Additionally, ITSE is hosting a conference this June. One of the themes is AI, so I think it will be a great opportunity for networking and staying up to date on the latest trends in AI education. And I want to close with another quote. So a year ago, the AI conversation centered on plagiarism and bans. Now most guidance focuses on urging educators to accept AI and use the technology. Kids AI aims to bridge the gap, ensuring that all students have access to education about generative AI. Join us in making the future a place for students to learn about this with confidence and critical thinking. Thank you.
So some of the issues around the critique of AI are interesting in that they touch upon diversity, equity, inclusion, and accessibility issues. And I'm wondering, especially, and take your time, I think it might be pointed more toward, there you go.
There we go.
And especially now, I'm just wondering how you plan to navigate that space when some of those issues, especially for the K through 12, are being banned or
I think that those will really be developed in collaboration in the testing to see like what is appropriate, what are the students responding to. I think they will also be targeted at different age groups. So like this is not an example that a 5th grader or a 3rd grader would be receiving. And I think it's really going to tie into what are the students using it for and what do they need to think about. So, I think high schoolers are going to be ready to start thinking about, who should be represented and like what changes. One of the things that is really important, you can see this in the reflect thing. I want the students to also reflect on like, what could the person who was prompting have done better here? Because they were very generic. So if we know AI is going to be biased, what can we do to say like, I want a diverse, representation, and you now have that on you to make sure that you do that.
So being at central office, there's not a day that goes by that I don't get something about AI.
Yep.
And people are freaking out about it.
They are.
And I truly believe that we should embrace it. So I'm a huge fan of this, although my teachers would freak out.
Yes.
Because they're still scared of it. So I'm wondering, when you're talking about teacher professional development, how might that look?
Yeah, so it is interesting. In all of the interviews that I conducted, every teacher said, I'm ready for it, but everyone else is afraid of it, which I thought was really interesting because every single one of them said that. So I think a lot of them are also afraid to admit that they're willing to do it. One of the big things that came up was that there's no guidance at the district level. So they're afraid to affiliate themselves with it because they don't know if there will be repercussions, since there's no guidance at this point what they should do. So I think a lot of the professional development would be targeted at getting the teachers comfortable with the tools. A big thing I heard from all of the teachers as well is that all they've really done is play with it. So they're afraid to put something in front of their students that has such big implications that they themselves don't really understand. And they're not getting any development on it. They're not getting any guidance on it. It's all themselves. So I imagine it being in the earlier stages, like a workshop, like coming in, having the teachers look at it, explaining each of these things, especially in the critique aspect of it, like what do they need to be on the lookout for? And, a lot of the concerns from teachers is also like, they're just going to use it to write an essay. But the reality is they're going to do that anyways. They're already doing that. And so if you can instead, I don't think a lot of the students realize that they're setting themselves back with that. They think, oh, it's easy. I don't want to write this essay, so I'm just going to have ChatGPT do it. But if they do that for, every essay, they're never going to learn those skills. And at 14, they don't see that future. So I really want to make that, especially in the learn portion of this, like have them see like, what are the repercussions of doing this? And like, you need to learn the skills, but also there are a lot of things this can do to benefit your education. So how can you use it effectively?
I'm sorry. Have you also thought about working with districts on district policy? Because that comes up a lot as well.
Yeah, and I think that is a big step. I think it would be hard, just getting the right connections with people to do that. There are currently 5 states that have issued actual guidelines on how to incorporate generative AI into classrooms. So I think those might be a good place to start. But yeah, I do think that it's important to start at that level because there is hesitation otherwise.
Thank you.
Yeah.
Have you given much thought to selling it directly to the states, like to a state?
That would be a great idea. I don't know.
I would encourage you to do that.
I love that idea.
There's a number of software companies that get these agreements with states.
Yeah.
And then they get the first state, they get the second state. Next thing you know, it becomes the standard.
Yeah.
Okay.
That's great.
Last questions?
All right.
We're all questioned out. Thank you, Jessica. So, and another big round of applause for all of our teams tonight. Super, super impressed. You can see why I was so excited. Again, slide magic. So in just a moment, in fact, I'm going to ask the judges to gather your materials and start to file out to the room our deliberation room. And then I'll ask Darren to come up.
All right. Well, thank you everybody for the great questions and competitors, pitchers. Thank you for your great answers.
Good timing.
Yeah, perfect timing.
Yeah.
And here's the moment you've all been waiting for.
It's pretty tight. Gosh, thank you. Always a bit of a tightrope, but we have the results. I should say, team, stay after for some photos, please. And the judges were really excited to offer feedback, connections, networking. So I sense we'll be sharing some emails around if that's okay. And please take advantage of these fabulous folks because there was lots. If we could sort of bottle what happens in there, we could. But for now, oops, of course. Look at that. Can you believe this? Great. Where did that slide advancer go? That pesky one. Thank you for rolling with our tech issues. The teams are super gracious. The slides were amazing this year, as were the ideas. Okay, the winners, the moment you've all been waiting for. So for our development awards, for Maximum Drama, our first development award goes to Math Myths for $2,000. Congratulations. Our second development award this evening goes to String Theory for $2,000. Our third development award goes to Climate Chaos for $4,000. Congratulations. Our fourth development award goes to, and then the drama will be less dramatic, Code Block for $4,000. Congratulations. And if you're paying attention, you will know that our Learning Levers grand prize winner this year, really exciting. Congratulations, Jessica. $10,000 for Kids AI. Yeah, keep the applause going, please, for all the teams. Super impressed this year, and thank you, everybody. Thank you, judges, for your participation. Round of applause for our judges as well. And thank you all for coming. Feel free to stick around, talk to folks, talk to our teams. Congratulations again. Please stay in touch with us. We'd love to know what you do from here, and please consider us resources as you sort of move into the next phase of this this project. So thank you all. Jose here. We'll do some pose photos at the front. Great. Thanks, everybody.